next, we are going to talk about the gear classifications. We have some types, different types of gears, so we need to learn a little bit about them. As I said, when you have access to these PowerPoint slides, please click on these links. It will open very interesting YouTube videos for you. But if I kept opening those YouTube videos, the lecture is going to be very long. I don't want to do that. You can watch them in your own time. So first, the types of gears. We are going to classify gears based on arrangements of shafts. Arrangements of shafts means that we have the axis of the two shafts with parallel axes, for example. So you have two, as I said earlier, you have the first shaft here and the second shaft here, and the center line of shaft number 1 and shaft number 2, it's perpendicular to the screen, okay? Or you have, for example, here, similar to this, you have the center line of the first shaft here and the center line of the second shaft here, and these two are parallel to one another. So in this case, we use what's called, for this purpose, we use spare gear, for example. Spare gear here, if you look at this gear, you will find that the tooth of the gear is parallel to the center line. So it is the tooth is like this in this direction, so are parallel to the center line of the shaft, okay? Or we can have helical gears, and there is a reason for using helical gears as well. But for helical gear, here the tooth has a specific angle with the center line. It is called helix angle. For example, we can also, if you consider the rack here and pinion, so this is pinion, and this is rack. So if you consider the rack as another gear, but with the diameter of the rack is infinity. If you consider the rack is another gear with infinity, with diameter goes to infinity, so it is like straight line. And here in this case, we can convert the rotational motion into linear motion using the rack and pinion. But here we convert this motion here to another rotational motion between two parallel shafts. Also, we can use internal gears. In internal gears, if this is the one gear and then another gear here, so they rotate in the same direction, okay? So this gear rotates in this direction and this gear rotates in the same direction. So if you want the two gears to rotate in the same direction, you can use internal gear. So for spare gears, the first option here, this one, there is some limitations on the velocity ratio. It is the maximum velocity ratio that can be achieved through spare gears is 8:1. Some advantages of spare gears, the efficiency is quite high. They are compact and easy to install. They are reliable. They don't break easily. And also they can transmit large amounts of power, like almost 50,000 kilowatt. Some disadvantages of using spare gears, they are costly compared to other power transmission drivers like belts, for example, or chains, etc. We have limited center distance here. As I said, if the center distance becomes large, so the gear size becomes large. So we have to use them within specific center distance. So they sometimes, for this particular type of gears, they produce significant noise at high speeds. For helical gears, the second type, so the teeth engagement here is more smooth compared to the spare gear, because for the spare gear, when two spare gears they engage, so here the engagement is on or the contact between the two teeth is on a line. But for helical gear, the contact between the two teeth, they are gradual. So they just mesh or they contact each other gradually in a point by point. But here, the engagement for spare gear is on a line. That's why it produces some noise compared to the other one. So here, the helical gear, it is engagement is more smooth and quiet compared to the spare gear, because the engagement is happens gradually. That's why they have higher operating speeds. So you can achieve higher operating speeds with helical gears. They can also transmit very large amounts of power compared to the almost double the amount of power that can be transmitted by the spare gear. Okay, so the loads distribution as well becomes like or produces less wear because of the engagement is gradual between the teeth. So of course there are some disadvantages as well in this. So first, in this case they produce thrust force. Thrust force is the force in the same direction as the center line of the gear. So it just means that when we design the shaft and the bearings, we have to select a bearing that can take thrust load. So for the spare gear, we don't need that. So spare gear does not produce any thrust force or any force along the center line of the shaft. But here for helical gear, it produces some thrust force or axial force, and this has to be accounted for when we design or select bearings. So the type of bearing that is used here has to take some thrust load. You will be learning more about bearings in the future, and you will get to understand that there are some bearings or some types of bearings, they can take the axial load, some other types, they cannot take the axial load, and so on. So, there are the sliding friction here is more, so the power loss is more, and consequently the efficiency is less. So if we have two shafts and the two shafts are intersecting, the previous type was like two parallel shafts, but here we have two intersecting shafts. So you see here, for example, the center line of this shaft is in this direction, and the center line of this shaft is in this direction. So we have two perpendicular shafts here. So they don't have to be perpendicular, but they can be at any angle. But in this case, we use what's called bevel gears. And as you see here on the screen, there are different types of bevel gears. We have mitre gear. Mitre gear, the pinion and the wheel, they have the same size. So these two of the same size. We have straight bevel gear. So the teeth here on the bevel gear here is like conical gear. It is straight. So all the teeth here are straight. We have a spiral bevel gear. So the spiral bevel gear here means that the teeth here are spiral. So it is like kind of similar in the same way as the helical gear. So you see here that we have mitre gears. We have this shaft here is in this direction, the other shaft is in this direction, and the angle between them is 90 degrees. So using bevel gears, they are just part of a conical shape, so they can be used to transform the power, the motion between these two shafts. There are some advantages and disadvantages, of course, of this type of gears. So it allows change in the operating angle, as you've seen, like you can transform the power and the motion between two perpendicular planes, for example. And then you can, based on this, the ratio between the pitch diameter of both the pinion and the gear, you can allow for something, what's called mechanical advantage. You can allow for increasing the torque or decreasing the torque, etc., as we have learned before. So you can change the ratio of the teeth, the number of teeth on the pinion and the gear, and consequently this will enable us to change the ratio of the speed and the ratio of the torque or the mechanical advantage. Okay, some disadvantages of this type of gears. So they are designed to work with complementary wheel only. So it means that you have to have two bevel gears. You cannot have a spare gear with bevel gear, for example. So they have to be of the same type. They must be precisely mounted. The shaft bearings here they must take the axial load, and this similar to the bevel gear, similar to the helical gears. So there is a specific type of bearings must be used with this type of gears. The next type is if you have two shafts and their axes are not parallel and are not intersecting. This is skewed, so they have two skewed axes. So in this case, we can use screw gear. These are kind of two helical gears. So, but you see here the axis of this shaft is vertical, and the axis of this shaft is horizontal. And then they are not intersecting, they are not parallel. There is a distance between them in the two planes. So we can use this type of gears to transmit the power and the motion between these two shafts, something like this. We can use what's called the worm and worm wheel. So if this is the worm, and this is the worm wheel. Sorry, this is the worm, and this is the worm wheel, I'm sorry. So in this case, you have two skewed shafts here. They are not parallel, they are not intersecting, so you can transmit the power and the motion between these two shafts using this type of gears. Of course, there are some advantages. They operate silently, smoothly. They are self-locking. Self-locking means that it just rotates, and if the rotation stops, it does not rotate in the opposite direction. Okay, so it locks. There is it's like a brake applied to the two gears. Okay, they occupy less space. They have here high velocity ratio. It's like in the order of 100, for example. So you can reduce the speed, rotational speed by 100 times, for example. So it means that if the worm rotates 100 times, so the wheel rotates only one rotation, which is very, very high velocity ratio in one step. There is lots of sliding here in this type of gears. So it means that the friction is high, temperature is generated. We need to use specific type of materials that could be expensive. Also, this leads to power loss and low efficiency.